Hello children, hope you are doing well. So today I am going to teach you a lesson in Form 3 Science, Metal and Non-Metal. So you will learn this lesson under second term from page number 120 to 131. Okay, let's move forward to find out learning objectives of this lesson. Learning objectives of this lesson. At the end of this lesson, you will learn about location of metals and non-metals on the periodic table. And also, you will learn to compare the differences between metals and non-metals. Also, you will learn about basic properties of metals and non-metals. Also, you will get aware about the way of obtaining metal from the process called electrolysis. And you will learn about the reactions of metal with the dilute acids. Metals and non-metals. Okay children, what do you know about the metals and non-metals? Are we working with metals and non-metals in our day-to-day life? Yes, we are working with the devices which made with the metals and non-metals. So, the thing called metals and non-metals have very different physical and chemical properties. Therefore, these metals and non-metals have different position in the periodic tables as well. Now you are seeing a periodic table here. Okay, now carefully see, in this periodic table, the elements are colored with three different colors: blue, green and yellow. So, the metals are represented with the light blue color and non-metals are represented with yellow color. The metalloids, or we call them as the semi-metals, are represented with the green color. So, we can interpret that in the periodic table, metals are located on the left hand side while non-metals are located on the right hand side. When we move across the periodic table from left to right, what happened? Their metallic properties decreasing and their non-metallic properties increasing. Okay, so I have shown you that fact using a nice diagram here. And also already we have learned the elements which located in between the metals and non-metals in the periodic table is known as metalloids or semi-metals. You can use any it's up to you. Okay, so what you have to keep remember, when we are move across periodic table left to right, there are non-metallic characters or non-metallic properties always increasing and metallic properties decreasing. Okay children, now we are going to learn about some physical properties of metals and non-metals using a table. So here I have given some example for some metals and their properties. So first metal that we are observing is sodium. So you can see this is an image of sodium, and basically this sodium have low melting points and the boiling points, and they are very soft. Sometimes we can cut them with a knife easily, and they have a low density and they are malleable. And the second metal is the chromium. Okay, so this is an image of chromium metal. And what are the special properties of chromium metal? They also have high melting point and boiling points, and they are very hard. We can't even think them to cut. Okay, and they have high density. So third metal is in here is aluminium. Normally in our day-to-day lives we are using so many devices which made with aluminiums, right? Some saucepans and different containers which made with aluminium, tins and all. So what are the properties of these aluminium metals? They have high melting points and boiling points, and they are very hard and having a higher density. That's why we can gain so many advantages from aluminium metals. Okay, in this slide I am presenting some non-metals as well as some metalloids with their properties. So what is the first non-metals in this table? Yes, it is the carbon. So this is the image of carbon. We know most almost every time we are using carbon, right? some carbons which are in our pencil tips, and there are some carbons in different devices. Okay, so we'll look at on properties of the carbon then. The carbon having high melting and boiling points, and they are very hard. When it is a diamond, it is very hard, but when it is graphite, it is soft. These diamond and graphites are both composed with carbon. Okay, so and carbon commonly having high density. And then our second nonmetal is fluorine. So this is a image which showing this fluorine. So fluorine have low melting and boiling points and low density. Okay, so these are the two nonmetals that we are learning in this lesson. Then we are coming to metalloids. Metalloids means the elements which in between metals and nonmetals in the periodic table. Am I right? Okay. Then the one metalloid that we can learn is silicon. Okay, so this is an image of silicon. So what are the properties of this silicon? Yes, they have high melting and boiling points, and they are hard and brittle. And there's a special property: these metalloids can conduct electricity easily with the temperature increases. Okay, so we have learned about three metals and their properties, two nonmetals and their properties, as well as metalloids and its properties, right? Okay children, now we are going to find out basic properties of metals. So first property is hardness. So are metals harder than the nonmetals? Yes, your answer should be yes. We have seen so many metals are very hard, right? So as we thought, metals are much harder than the nonmetals and much flexible than the nonmetals too. Okay. And our next property is malleability. What is the meaning of malleability? That means when we are applying a force, the atoms which made this metal is slightly move aside. Okay, that means metal can be beaten into thin sheet because of the ability of atoms to roll over each other into new positions without breaking. So here in this diagram you can see for this metal to two different positions these forces are applying. Okay, what happen when these forces are applying? It is something like a pushing these atoms from here, right? Then what happen? Those atom layers are slightly move forward and make a new position without breaking the metal. So we call that property as a malleability. Okay. Okay, our third property is the ductility. What is the meaning of ductility? It is the ability to stretch into metal to a wire when we pull in it. Okay, almost all the pure metals are ductile. That means when we are just applying forces on metal and when we are stretching with it with a higher force, we can make into a wire without breaking. Okay, so almost all the pure metals are these kinds of ductile. So we call that property as a ductility. The next property is density. Most metals have higher densities than the non-metals. We have seen this, right? They are very tough. We can't press or we can't cut them easily, right? Because they have higher densities. But some metals which are laying on the left of the periodic table, okay, some metals such as lithium, sodium and potassium, they have low density. That is the exception. Okay, I mean the except lithium, sodium, potassium, and there is one metal called mercury. Other metals are high dense metals. Okay, normally these lithium, sodium and potassium have low densities. We can cut them with a knife also. So much softer than the other metals, these metals. So you can refer simple experiment to aware about the densities of the metals and non-metals, which is in the page number 123 for further knowledge. The fifth property is strength. So you may have experienced this when we are working in day-to-day life, and when we generally hold a tough of objects, we used to say that oh, this is stronger like metal, right? So from that we have some idea that metals having a higher strength than the non-metals, right? So metals, yes, you thought correctly, and metals have the ability to withstand heavy loads without breaking easily because they are very strong. Due to this property, metals are taken for heavy machineries and the vehicles. Okay, so you can refer the activity which is in the page number 124 and can gather information from internet about the strength of given metals. Okay, so the next property that we are going to learn is melting and boiling point. If you remember, in that table we have talked about so many things regarding melting points and boiling points of the metals and non-metals, right? So we are going to find out what kind of melting and boiling points are in the metals and non-metals. Okay, so most metals such as magnesium and aluminium have high melting points, while sodium like metals have low melting points. Okay, that means we can melt them easily. We can make them a liquid in low temperature. That is the meaning of low melting points. Okay, so then what about the metalloids, Pute? Now we know that the metals have higher melting points than the non-metals. Then these metalloids, they have wide range of melting points. I mean, they don't have exact value. They have a wide range. Okay, as I told you earlier, most non-metals have comparatively low boiling point. So I am going to confirm my idea by using a graph. Okay, here you can see as we already learned, sodium, magnesium, aluminium are metals. Then silicon, it is a metalloid or semi-metals, and rest are the non-metal. So we look on this. So in here the red color bars are representing the boiling points and green color bars are representing the melting point. Here it is given, right? So you can see in the metals, red color bars having higher values than the non-metals, right? Because they are they have a higher weight than the non-metals. So we can easily say, or we can confirm, that metals have higher boiling points than the non-metals. Okay, then what about the melting points? The bars which represented with the green color, can you compare the green color bars of metals with the green color bars of the non-metals? What happened? Their height is much lower than the metals. Okay, so we can say that also metals having a higher boiling points, higher melting points than the non-metal. What about these metalloids? We can't, I mean, there's no exact value. They have a wide range of melting points and boiling point depending on the type of element. Okay. Okay students, I believe that you have got a real understanding and good awareness about the properties of metals. And now we are going to find out what are the unique properties of metals. Okay, there are some metals which have unique properties which only inherited for them. So most metals are hard and high in density except sodium and potassium. That is exception, right? We have learned that earlier. So it is a unique properties of sodium and potassium. And these can even float on the water due to less density. That sodium and potassium also having a low density than the other metals. And though most metals are magnetic, Some metals such as gold and copper, they are non-magnetic. That means the gold and copper cannot attract any metallic things to it. But other metals, they have magnetic properties. So, most metals are solid in the room temperature, but the metals like mercury is in liquid state in the room temperature. What is the mercury, Pute? Where we can see mercury? If you have seen a thermometer which is in your laboratory, the thermometer is using a metal called mercury. It is in a liquid state, not a solid thing, right? So those are the unique properties of some metals. Okay children, have you ever think about the way of obtaining these kinds of metal? What are the methods that we are used to obtain these metals? Yes, your answer should be electrolysis. Okay, the process is electrolysis. Electrolysis can be defined as the process of breaking down a compound into elements with the use of electricity. So in this slide, I am going to explain the way of obtaining sodium metal from sodium chloride. So to do this practical, we need these apparatus. So you need to have molten sodium chloride and 2 electrodes, 1 electrical source and some connective wires. So as soon as you connect these apparatus like here, that means when you connect these that means power source to the electrodes, and you have to keep it some time. When time passes, you can see some observations, some changes which happen near the negative terminals and positive terminals. So why I am telling this as a negative terminal and this electrode as a positive terminal? Because this electrode is connected to the negative terminal of the battery, and this electrode is connecting to the positive terminal of the battery. So we'll find out what are the changes which happen near the positive terminal and the negative terminal. So when sodium chloride is electrolyzed, sodium metal is formed at the negative terminal. Okay, you can see some metals are depositing on the negative terminal, as well as you may see that chlorine gas is formed at the positive terminal. That means some gas bubbles will be evolved from the positive terminal. Okay, so if we interpret this reaction, at the end of this reaction you can think that sodium chloride is dissociating, that also, or else it is separating into sodium metal and chlorine gas. So by carrying out these kinds of electrolysis, we can obtain pure sodium metal. Okay, I believe that you got to understand this process well. Reaction between metals and dilute acids. Normally, when metals react with the dilute acid, it always produces salt and hydrogen gas. This is a common relationship. Any metals react with the dilute acid, it results salt and the hydrogen gas. Okay, let's find out how magnesium metals will react with the dilute acid. So in this animation you can see, when we are adding magnesium strip into a test tube, it will vigorously react with the dilute HCl acid by emitting some air bubbles. You can see some air bubbles are going up. Okay, it is a vigorous reaction. So let's find out what will happen then. Magnesium, when react with the dilute hydrochloric acid, it will produce magnesium chloride and hydrogen gas. Magnesium react with the dilute hydrochloric acid, it will produce salt. This is the salt, magnesium chloride and hydrogen gas. Here I have given word equation and the symbol equation both. When magnesium react with the dilute HCl, it will result magnesium chloride and the hydrogen gas. The name of salt produced will depend on the metal and the acid used in the reaction. As this table shown you, if you use dilute hydrochloric acid, it will form chloride salt. As well as if you use dilute sulfuric acid, it will result to form sulfate salt. Also, if you use dilute nitric acid, it will result with forming nitrate salt. Okay. And if magnesium is used to react with the acids shown in the table above, you will get of these following salts. Here I have given 3 columns. First column giving you the name of metal. Second column giving you the name of the acid used. Then here I have given the name of salt produced. So when magnesium metal react with the dilute hydrochloric acid, as we learned earlier, it will result to form magnesium chloride salt. Can you see? Magnesium part is coming from the metal. Chloride part is coming from the acid. Likewise, if we carrying out the reaction between magnesium, metal and now it is dilute sulfuric acid, then you will begin magnesium sulfate as the salt. And if we carrying out the reaction between magnesium and dilute nitric acid, you will be have magnesium nitrate as the salt. Can you understand? Depending on the metal and acid that we are using, the salt can be vary. So children, I believe that you have learned about more about the metals and nonmetals and so many new things. So now we are in the summary of this lesson. So in this lesson, you have learned that metals generally tend to locate in the left hand side of the periodic table, while nonmetal located in the right hand side. And you have learned about the metal properties such as hardness, density, ductility and malleability. Also, you have learned about the electrolysis, process electrolysis, and you have identified that electrolysis is mainly used to obtain the metals from metal solutions. When metal react with the dilute acid, it always form salt and hydrogen gas. We have did many examples and I believe that you are expert on that now. So those are the things that we have learned from this lesson. Okay, here I have included some exercises and references links for you. Under the exercises, you have to follow the revision questions which is in the page number 130 in your textbook. And also, you can do the workbook exercises from page number 60 to 65 in order to polish your knowledge. And here I have included some reference link. Please go through these references and find more about the metals and nonmetals. Okay children, this is the end of this presentation. So thank you for listening. Stay safe. Goodbye.